Hello and welcome to this video lecture about pretreatment. My name is Bas Heijman and I'm an Associate Professor in Water Treatment. During this lecture, we will first look at the pretreatment steps seen in the online excursions. Then we will focus on pretreatment in relation to different fouling types. If we compare the pretreatment steps shown in the video excursions, it's clear that different feed water qualities require different pretreatment. The seawater desalination on the ship had a hydrous clone for coarse particles, a multimedia filter for small particles, an anti-scaling dosing step to prevent scaling. Cartridge filters are always used to protect the membranes and the high pressure pump. The drinking water plant used anaerobic well water, and the pretreatment was only limited to a cartridge filter to protect the membranes and an anti-scaling dosing to prevent scaling. The industrial demineralized water plant, which will be visited next week, has the most extended pretreatment with conventional particle removal. The scaling is in this case prevented by removing the multivalent positive ions with a cation exchange resin. Also here a cartridge filter is protecting the membranes. In order to tackle different types of fouling, we should evaluate possible actions in pretreatment, in the membrane process and in cleaning. Through pretreatment, there are good opportunities to tackle particulate fouling and scaling. Biofouling and organic fouling are more difficult to prevent with pretreatment. I will discuss now the different fouling types separately in relation to pretreatment. Rapid sand filters are used as pretreatment steps against particulate fouling and can remove particles larger than 0.5 micrometer, especially in combination with coagulation. The filters are clogging in time due to the collection of dirt between the sand, and the consequence is that the resistance increases, so also the head loss increases. In this case, the water level above the filter rises. If the maximum head loss is reached, the filter should be cleaned with a backwash. With a backwash, we reverse the flow in the filter and the sand is fluidized. The water rises again until the backwash gutter, and the dirty water is leaving the filter through this valve. In the fluidized state, all the dirt can be washed out and the water becomes clean after some time. Ultrafiltration is also used for removing particles before nanofiltration and reverse osmosis. Ultrafiltration is very compact compared to conventional treatment, and it removes particles down to 0.02 micrometer. In this animation, an outside-in operation is shown, but inside-out operation is also possible. The membranes are clogged during filtration and can be backwashed in order to remove all the accumulated particles. The advantage of the small pore size in the walls of the capillaries is that biopolymers are also removed. These type of polymers are produced by bacteria and fresh surface water or seawater and are very sticky to all membrane surfaces. By removing them in the ultrafiltration, fouling of nanofiltration or RO membranes is prevented. A UF membrane can be cleaned with a backwash and can be daily cleaned with chlorine. Backwash nor chlorine cleaning is possible in nanofiltration and RO. Scaling can be prevented through pretreatment. Acid dosing is only efficient for calcium carbonate and calcium phosphate scaling, but is not able to prevent sulfates or silica precipitates. Anti-scalant can be used against carbonates, phosphates and sulfate precipitates. However, silica scaling is only slightly prevented by anti-scalant dosing. Another approach is to remove scaling ions from the feed. By removing multivalent positive ions like calcium, magnesium, barium and strontium from the feed with an ion exchange softening column, scaling of carbonates and sulfates is prevented. With conventional softening, the same ions are also removed, but not to the same low concentrations as achieved with ion exchange. Silica is the most difficult scalant to tackle. Silica scaling is also impossible to clean from a spiral-wound membrane. So it's very important to keep the silica concentration in the last membrane element below 150 milligrams per liter silica. By adding antiscalant, a maximum concentration of 300 milligrams per liter silica can be allowed. Further information on scaling is given in a separate lecture. From the video excursions to the drinking water plant, you learned that anaerobic well water has no biofouling potential in the membranes, as long as it's kept anaerobic during filtration. In the case of biofouling prevention, successful pretreatment with activated carbon or biofiltration is shown for surface water and wastewater. Chlorination and dechlorination can sterilize the feed water, but biofouling can still occur in the feed spaces because the membranes themselves are not sterile. Further information on biofouling is given in a separate lecture. Organic fouling is in most installations not an important problem. A thin layer of organic molecules adsorbed on the membrane surface can increase the membrane resistance. However, the cross-flow will limit the development in thickness of this layer, so there will be no progressing problem in time. The conclusion is that the needed pretreatment strongly depends on the raw water quality. The main goal of the pretreatment is prevention of particulate fouling and scaling. Some feed waters need pretreatment for biofouling, but this pretreatment can be expensive and can never prevent biofouling to the full extent. Thank you for your attention.